Booking limits and protection levels. Two examples of revenue management techniques that we will consider in this course will be one with booking limits and protection levels, and the other will be with overbooking. In the case, in both cases, I will show you that the same logic of the news vendor model applies in both of those examples. So basically, there will be a problem of having too much or not enough of something. And we will start with booking limits or protection levels. And the example will be a hotel which has 118 rooms, and the hotel already decided the pricing, so it's not exactly as flexible as we had in our general example of maximizing revenue, right? We're not going to vary the prices and then decide or try to sell the quantities, different quantities depending on the prices. Here, the problem is we fix the prices, right? And then we try to determine or to maximize revenue by varying quantities we sell at a higher price or at a lower price. This is actually what typically has to be done because prices you have to announce ahead of time, and then customers have to decide if they are willing to pay this or this price or not, right? So you have to commit to prices, and now the decision is just how many rooms do you sell for this price and how many rooms for this price. We're just assuming optimization for one night for those 118 rooms. So the lower price will target leisure travelers, while the higher price, 225, will target business travelers. Now, because these are leisure travelers, we assume at this price we can sell all the rooms, so the demand for this low fare is abundant, but it occurs long before the date of stay. These are leisure travelers who plan their holidays ahead of time, a month before, a few months before even. Before they travel, they book, right? And so we don't expect a lot of this demand to happen last day, 2 days before the date of stay. However, for the business travelers, we expect the demand to occur mostly within a few days before the day of stay. So now we have a problem that if we sell all the rooms to the leisure travelers, nothing will be available for the business travelers, right? And so we have to somehow protect these rooms for business travelers, but the demand for business travelers is uncertain. So here we are going to assume the high fare rooms, right, have demand D, which has Poisson distribution with the mean 27.3, and that occurs mostly within a few days, before the date of stay. So here the problem becomes we try to maximize expected revenue by controlling the number of low fare customers that we sell ahead of time, and this is what we call a booking limit. So the booking limit and protection levels are actually booking limits and protection levels are two alternative ways of defining the same kind of restriction. A booking limit is the capacity, or in our case, the number of rooms that we're willing to sell in a fare class or lower, right? So here, because we only have two fare classes, right, we would have a booking limit for the low fare so that enough can stay available for the high fare. Protection level is the number of rooms in this exercise, or in general, some capacity that we want to reserve for a fare class or higher. In this case, we can define protection level for the high fare, right? How much do we have to protect? I hope you see that if you have a hotel with 118 rooms, if you limit the low fare to 100, let's say booking limit, if this one is 100, that's the same as saying the protection level is 18, right? Because the total number of rooms is 118. If we book, put a booking limit 90, this protection level is 28. So really, this is the same kind of decision that we're expressing. Now, this or lower or higher is just because if you have more than two fare classes, right? The price more than two different prices for the same room, then you can define booking limits and protection levels in a kind of nested fashion. So you might say, I am putting a maximum number of 70 rooms to be sold at a price of 159 or lower if there are lower prices, right? Maybe I would have a third price. And so they are defined in a nested way. So you could say for a price of $100, super saver, I'm booking limit is 20. For a price 159, the booking limit is 70, but that includes also the price 100 tickets, right? So there are nested way of defining booking limits and similarly nested way of defining production levels, but we will not go into this in this example. So we will define our decision, Q, quantity, as protection level for the high fare class. And the idea is as follows. We need to decide Q ahead of time, and it has to remain in effect while we sell the low fare capacity, right? So basically, if we decide to protect a number of rooms for high price, then 100 minus 18 is what we sell for the low price. So the booking limit for the low fare will be 118 minus Q, right? So we will sell no more than 118 minus Q low fare rooms because we are protecting Q rooms for high fare. Now, because we know our demand for low fare is abundant, right? We can even sell all 118 rooms if we want to. Of course, 118 minus Q, we will assume in our example, is going to be sold anyway, right? So we will assume whatever the booking limit, it will be satisfied. It will be those rooms will be filled with the leisure travelers who pay 159 per room. So the main observation now is that we have a single decision queue, which is protecting a number of rooms for high fare customers that has to be made ahead of time before the uncertain demand for those high fare customers, right, for the business travelers, D, is realized, right? So this is again a news vendor model. It's the same as ordering a quantity of products to be sold when demand is uncertain, right? In this case, the products are the rooms, right, on a particular day or night, right? And quantity Q is what we protect. So this is like we allocate for this demand, and then this quantity might be too large or too small. Therefore, we have an overage cost, right? And the overage cost is when we protect too many rooms and the demand is actually too small, some rooms remain empty. And because of this, we just lost the low fare, right? We could have sold those earlier at the low fare, right? But we protected them. We didn't. So we lost $159, right? And so the underage cost is if we protected too few and the demand happened to exceed quantity Q, then the problem is we no longer have rooms for the business travelers because we sold them for the leisure travelers. So we sold them at 159, but we now see it was possible to sell them for a higher price. Too late now, right? They were sold for 159, but the opportunity cost is the difference between high fare and low fare. If we protected more, if Q was higher, right? It is too low now, but if it was higher, we could have gained an additional $66, which is the difference between the high fare and the low fare, right? So we have overage and underage cost. We can use our news vendor model. We can calculate the critical ratio as before, and the cost of underage divided by the sum of cost of underage and overage. If you plug in for those costs, right, for overage RL and for underage RH minus RL, you see that the numerator becomes the difference of those costs. It's just CU, whereas in the denominator, there is RH minus RL and then again plus RL. So RL disappears in the numerator. You get a critical ratio of almost 0.3. And that actually tells you that we should try to go for the quantity that is actually below the expected demand. How much below, of course, depends on the standard deviation. If you recall, demand D was with Poisson with mean 27.3, we can use the Poisson news vendor model and determine that the optimal quantity is 24, which is indeed below the expected 27.3 demand. So that means 24 rooms should be protected for high fare customers. And in other words, right, booking limits should be, right, it's 118 minus 24, which is equal to 94, right? So at most 94 rooms should be sold to the leisure travelers for the low fare. So we can also calculate several measures based on the news vendor measures. If we ask ourselves how many high fare customers will be refused a reservation, this is expected lost sales, because remember, the demand that we're talking about is for the high fare customers. And if we don't have, the quantity is too small, we have lost sales. So we can use the news vendor's expected lost sales, which is now 4.1. So we should expect on average 4.1 customers with that business travelers to be refused reservation, right, with the quantity, the protection level Q24 that we assumed. What about high fare customers who will be accommodated? How many of them will be accommodated? This is the news vendor expected sales, which, if you remember, is actually manually can be calculated as expected demand, which was 27.3 mu of the Poisson distribution minus lost sales, which is calculated here. So the expected number of high fare customers, the business travelers, will be 23.2. How many rooms will remain empty? Right? Remember the booking limit 94, we sell those, but those that are protected, the 24, out of them, we expect to sell on average 23.2. So the empty rooms is the news vendor's expected leftover 0.8. And what is the expected revenue, right? How much is the expected revenue? Notice this is a different formula than in the news vendor model. The expected revenue can be calculated as expected sales of high fare. Remember now, all the expectations are for the high fare customers, because this is the quantity, that quantity is protection level for high fare and demand is high fare demand. So expected sales are expected sales for high demand, right? This is the value, 23.2. And this is what we will sell for 225. This is the expected revenue from high fare customers. And from the low fare, we will get 159. That's actually not expected. That's a fixed value, because we assume we will sell a booking limit 94 rooms at this low price, right? For sure. That's the assumption in our model. Of course, this is a simplification just to make our calculations easier, right? But assuming the demand is abundant, this is what we will realize. So you can see the summation of those two costs, and it's 20,000. Sorry, summation of those two revenues is $20,166 of revenue in total from both fare classes. Now, notice if we didn't use the revenue management and we just sold, for example, all the rooms to the leisure customers, not protecting anything for the business customers, we would have a revenue of 18,762. That means the revenue management increases the revenue here by 7.5%. And so, I hope you see this seems like a small percentage, but if you recall from our revenue change to profit change arithmetic, this might mean a very large increase in profits.